All right, so now we have a slightly different problem related to the ellipse. We're given the center, a focus, one focus, and one vertex. And what we need to do is that we need to come up with an equation for an ellipse that satisfies this information. Well, the best thing to do is to start off with the basic form no matter what. So that basic form says x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Now, since they are already telling us the center is hk, we can go ahead and plug that in and say that we have x plus 3 squared over a squared. We'll have to figure that one out. And then we have y minus k squared, so y minus 2 squared over b squared is equal to 1. So we've actually got quite a lot here. We just need to figure out how does the rest of this fit in. Now, you'll notice that if you were to just graph this out, so we have negative 3, 2. We have a focus that's at negative 3, 5, so that's going to be up. So let's see, mark this as the center. And up here we have one focus at negative 3, 5, and then we have a vertex, call that V1, at negative 3, 6. So since a focus and a vertex is directly above or below the center, that means we're stretched more in the y direction, which means b is going to be larger than a. We can go ahead and find out what that b value is, because from the vertex to the center will be the b value. And from the focus to the center is going to be your c value. So we can easily answer some stuff with that, and we know how a, b, and c relate. All right, so b is larger, and the change from 2 to 6 is 4. So that means that b equals 4. And the c value, as we go from the center to one of the foci, is 2 to 5. So that means that c equals 3. That's just the change from 2 to 5. Now, remember what we said before. We said that in our forms and all that stuff, we said that c squared is going to be the difference between a squared and b squared, where you want to make sure that you have the larger number first, right? So we know that b is going to be the larger one. So it's going to be b squared minus a squared for this example. So we plug in what we know. So we have 3 squared is equal to 4 squared minus a squared. We can work this out, and it shouldn't be any problem at all. Now, the first thing that we should do is to move the a squared to the left. So that makes that a squared positive. This 4 squared is 16. If I move this 3 squared to the right, that gives me 9. So that means a squared is equal to 7. So from here, we can answer every other question that we need to about this problem. So if a squared is 7, that means that a is the square root of 7. So that makes our form, our full equation, to be x plus 3 quantity squared over a squared. Now don't write square root of 7. It's that squared, so it's going to be 7 plus y minus 2 squared over b squared, so b is 4, and we'd have 16. And that equals 1. So we already have the center. One focus is at negative 3, 5, so the other focus is going to be at negative 3. So look at this. From the center to the first focus, you were going up 3. So let's go down 3 from there, and that would be negative 3, negative 1. Well, what about the other vertex? Well, the one vertex was 4 units above the center. So let's go 4 units below the center, and that's negative 3, negative 2. If I do the length of the major axis, that's going to be 2 times that b value, right? Because you're going 4 up, 4 down, so that's going to be 8. The length of the minor axis, that's a little bit more complicated, but the minor axis is going to be the stuff going out to the sides because the number underneath the x is a little bit less, right? And that a value we found to be the square root of 7. So that means the total length of the minimum, of the the minor axis is 2 square roots of 7. And if I were to try to find the endpoints of the minor axis. So you're going left and right, 2 square roots of 7 from the center. Now my center is negative 3, 5, so it's going to be negative 3 plus or minus 2 square roots of 7, comma 5. So going left and right from this center, oh, not 5, 2, my bad. So you're going to be going left and right from negative 3, 2 by not 2 square roots of 7. Guys, come on, now you're supposed to be helping me here. All I'm doing is making a fool of myself. There we go. Negative 3 plus or minus the square root of 7. See, I don't know where I was looking. I think I was looking up here for the length of the minor axis. But from the center, it's just the square root of 7 on left and right. And then my domain from left to right is going to be negative 3 minus the square root of 7 to negative 3 plus the square root of 7. And then my range is going to be going from a low value of negative 2 up to a high value of 6. So from negative 2 to 6. Which you'll see how all that kind of works out, because that's along the major axis. The length of the major axis is 8 units, and from negative 2 to 6 is 8 units. Okay, let's try another one. So we have a vertex, excuse me, at 5, negative 1, and we have an endpoint of the minor axis is 1, 1. So let's see if we can figure out what the equation is for this. Again, I think it's always a good idea to write down the basic form first before you start to plug in anything, before you start to mess around with any of this. Make sure you know what the form is. All right. Now you might think that I didn't give you enough information, but I told you a vertex and I told you a point on the minor axis, right? So if I were to try to graph this guy, so 1, 2, 3, 4, 5, and down 1, that's a point on the vertex, right? And the minor axis would be at 1, 1. So that means that the minor axis is that guy right there. So this is the minor. And the major axis has to be this one, right? Because just the orientation of these guys, you know that it can't be any other way. So it has to be elongated along the x as opposed to the y. And yeah, so I guess there really are like two possibilities for how we could connect these guys. But only there's only one way that this can make sense. All right, so if you think about the guys that we can draw here, I could draw an ellipse that does this, right? But that would put the point that's supposed to be on the major axis, 5, negative 1, puts along the minor axis. So that can't be right. The other option is to draw is to draw this. And that one does make sense, right? There's no really other way to do this because you can't stretch it anywhere else. So because of this, the intersection of these 2 points will be the location of our center. So the center will be located where? Okay, so this is the order pair 1, 1, and this is the order pair 5, negative 1. So the x value here is 1, and the y value here is negative 1. So this is a great place to start. Not only that, but we can measure the distance from the center to this vertex. So from 1, negative 1 to 5 is 4. So the way that we move along the x way, the way we stretch along the x, means that A is going to be 4. And the B is the stretch vertically, so from 1, negative 1 to 1, 1 is 2. So that's going to end up being 2 squared when we work it all out. So x minus h, so x minus 1 squared over, so this was 4, but it's going to be squared, so it's going to be 16, plus y minus negative 1 is y plus 1 squared, over my b value is 2, so b squared is 4. So that would be the equation of the ellipse that goes through those 2 points, where one is a vertex and the other is an endpoint of the minor axis. All right? And then from here, we should be able to answer everything else about, this ellipse. You've got the center. We could find the foci, but we have to find the c value, right? So c squared is 16 minus 4, which is 12, which means c is the square root of 12, and that becomes 2 square roots of 3. So my foci, again, we've been doing this for so many problems here. Hopefully you've caught on. The foci is going to will be left and right from the center. So that's going to be right and left, so the plus or minus 2 square roots of 3, comma negative 1. The vertices, we already know one is 5, negative 1. The other one is going to be 4 units to the left of this guy, so that's going to be negative 3, negative 1. The length of the major axis is going to be 2 times 4, which is 8. The length of the minor axis, 2 times 2, is 4. And the endpoints of the minor axis, so you're going up and down 2, so we already were given that one of them is 1, 1. The other one is going to be 2 units below the center, so it's going to be 1, negative 3. And then we can talk about the domain. Will be from, what is that? From negative 3 to 5. And my range is going to be from negative 3 to positive 1. Again, look at your picture. Look at the endpoints that we have for the vertices, for the endpoints of the minor axis, and it all falls into place. All right? Now, the next couple examples we do, the numbers are going to be bigger. But again, they're just numbers, so you're going to be okay.